Hi, everybody. I'm Mike. Mike Henein. Hello. I go by Noise Junkie Live on Twitter, and on Twitch, I'm Noise Junkie with a Z. I also have a company called VZR Audio. I'm actually building a, let's just call it an audiophile gaming product. It's still yet to be announced. So that's hopefully something we're trying to announce later this year. So maybe if you guys want to follow us on Twitter, that'd be great. And as we, put out stuff on it and make announcements, you guys can hear about it. So I want to thank, first off, DigiPen for allowing us to have this workshop here. I think it's an awesome facility. I really appreciate Greg for helping me put this together. Also, Ty and Kenley from SOBA. Appreciate you guys for helping out with this. We've been working on it now for a couple of months, and everything sort of converged, and we're glad to be able to do this. It's been mentioned that SOBA has kicked off a BroadcasterU initiative, and I'm really, really, really super stoked and thrilled and honored to actually kick it off with this workshop on audio. There are going to be future workshops talking about other aspects of online broadcasting that'll be announced, I'm sure, in the near future. I know that Ty touched upon that earlier, so I'm sure you guys will all hear announcements about that soon. The goal of the BroadcasterU is a program from SOBA to educate the local online broadcasting community in various topics. So that's just a really super awesome thing for the community, and I'm really thrilled that SOBA is doing that. And while this particular workshop is about audio, future workshops are going to cover all kinds of things, maybe video, lighting, and all kinds of cool subjects. So thanks everybody for making it out here. Appreciate it. And let's go ahead and get started. So the agenda today, I'm going to cover fundamentals. I'm going to go back a slide, actually. The name of the workshop is Fundamentals and Amping Your Content. So I'm going to touch just very briefly on the history of audio for broadcasting. I'm going to go into fundamentals of sound, what sound is, microphones, fundamentals of analog and digital audio, mitigating ambient noise, and I'm going to touch on a very basic level, some of the tools available for audio broadcasters, and I have a couple of demos I'm going to be showing as well. And so as I talk through each of these, sections, I'm going to open up for questions so everyone can have an opportunity to ask questions about each section, if that works for everyone, and then maybe do a final Q&A at the end. Does that work? Cool. All right. So without further ado, let's go ahead and get started. I'm going to touch on brief history of audio broadcasting. It's been said that we stand on the shoulders of giants. And broadcasting, I mean, if you really want to take it back, this goes thousands of years of human history. Just sitting in front of think about ancient Greece, in an amphitheater. Someone is performing a theatrical thing, or entertaining, or singing, or even a religious ceremony or something. They're broadcasting their voice across an amphitheater. I mean, this is something that is part of the human experience. But what's interesting is in the late 1800s, we started seeing some really cool things happen. This device actually is pretty, I think kind of kicked off modern broadcasting, and I'll explain why. It's called a théâtrophone, and in 1881, a gentleman named Clément Ader in Paris, France, attended the Paris Electrical Exhibition and was showing off a new system. And this system was pretty cool. What it did was it allowed for remote listening of theaters. So if you can imagine someone attending a theater, well, what if they're unable to actually attend physically? You know, they can actually listen to the theater at home. So how this system worked, and what he demonstrated, was a microphone pair that would be placed at the edge of the stage, okay? And using telephone lines, they would run the lines off to a telephone switching system where they have telephone operators. And if you were a subscriber, believe it or not, it was a subscription model, you can basically hear the audio in your home. This is late 1800s. We're talking 1880, 1890s. Now, what's really cool about this, if you notice, they're using two earpieces. So this system actually used two telephone lines, one for each ear, right? So that's interesting because it's stereo, it's stereophonic. And in some cases, they were actually doing 3D binaural sound. I'm going to touch on what that is a little bit later. But folks, this is pretty awesome. I just thought that this was, so why this is revolutionary and why this is pertinent, because this is the first form of electric or electronic transmission of sound, and in this case using telephone wiring. What's that? Before radios. Absolutely. So, and you know, there were different kinds of content actually. So aside from theaters, this developed and evolved, and programs such as news summaries, stock updates. There were, you know, entire programs and a schedule that was available for subscribers. But they even had these devices at hotels and in some public areas that were coin operated. So you can actually, you know, put in, I don't know, 1 franc, you know, and listen for 5 minutes. It's pretty cool. So yeah, so this started something. So an interesting fact is that, as you can imagine, this was before sophisticated amplification actually was invented. Things like vacuum tubes and transistors didn't exist back then. So they actually had to have very loud performers, right? So if someone, let's say, was doing a news summary, they had to literally shout, and you know, they had to have that ability to really carry themselves really well so that the transmission, so that the sound over the telephone lines didn't lose, you know, there was no loss. So they called them stentors. So I think that was just kind of an interesting tidbit there. And again, this system actually used headphones, so they had little earpieces that go in the ears. Eventually, in the 1920s, with the advent of vacuum tubes, they actually utilized the system and then allowed you to plug in a speaker so you can actually listen rather than everybody in the household having their own. Because think about it, that's 6 lines of wiring, right? For 2 for each ear. They could just set up a speaker and everyone can listen together. So, so Ty brought up radios. So in the 1870s, you know, one of the pioneers of electromagnetism worked out the theory, James Maxwell worked out the theory of electromagnetism, later proved by Heinrich Hertz. And ultimately, this led to the development in the 1890s of the very first long-distance radio apparatus that was wireless. So we're talking about now wireless radio happening in about the 1890s. And in 1900 and 1906 were 2 recorded instances of actual audio broadcast wirelessly. So we're talking now the very first radio broadcast done, one in 1900, and that was only a span of 1.5 miles. And then the following, or I should say 1906, that one was actually over several hundred miles. In fact, there's documentation of a ship that belonged to the United Fruit Company where the crew members were listening to the broadcast, and they were so smitten by how magical it was that they were actually able to hear something through sound with their communication systems. So that was pretty cool. So radio then starts to go prime time. In 1920, a company called Westinghouse saw an opportunity to get into the radio business. And later that year, the very first commercial broadcast happened in November 1920. And it was actually relating to the presidential election results of President Harding and Cox. So that was the first ever public broadcast by a station KDKA in Philadelphia. And in 1922, the very first radio ad occurred. And this was in New York City, and it was for a real estate developer. And between the span of 1920 and 1924, we started to see 600, there were now 600 commercial radio stations that existed. And in 1926, RCA, which is the Radio Corporation of America, formed the first national broadcast network called NBC. And so what we're starting to see here is that this is now becoming a serious business. And 1929, FM radio was developed as an improvement to AM. If you guys, anyone doesn't know, FM, frequency modulation, AM, amplitude modulation. We're not going to get into the physics of that, but by the 1950s, radio started to become stereo. And this was important so that musical performances and theatrical performances and all kinds of programs and content were now starting to actually have some very good fidelity by the 1950s. So what drove the adoption of radio? Money. Folks, this is all about advertising, okay? This is an ad play. There was money to be made because audiences were tuning in. And the big picture here is that production quality matters. Production quality and technology increased over time to ensure that audiences were satisfied. And I want to kind of drill this in everyone's head here, that if the audience is not satisfied, they don't tune in, okay? And when audiences don't tune in, there's no revenue. Advertisers go away, and the people creating the content aren't going to get paid. So just we have to care about production value. So this is why people got into the radio business. So moving on, let's really get into the what sound is and what are waves. Not that kind of wave, but Mikey says cowabunga. Cowabunga, dude. So that's my bad joke for the day. But sound waves. So let's talk about sound waves, what they are, what do they look like. So I'm going to stand up here a bit. And quite simply, sound waves are increase and decrease in atmospheric pressure, okay? So if you can imagine air in a room, as I'm speaking, there's actually minute changes of pressure across as the sound is propagating through the air. So we're seeing here, as the air molecules kind of bundle up together, that's a sign of increased pressure. Decreased pressure, they start to open up a bit, so on and so forth. So it corresponds, okay, so the atmosphere pressure changes correspond to a wave. So this is essentially a wave that's increasing and decreasing in pressure over time. So it's essentially air molecules that are bundling up and then breaking apart a bit. So we call this compression and rarefaction. And when I start the animation here, you'll see, so if you can imagine this is a sound emitting device or a speaker, you notice how it's moving back, it's a rarefaction. As it's moving in, it's pushing and creating higher pressure, so that's creating the compression. And this is the rarefaction as it pulls back, okay? So what's interesting here is that we can kind of track the wave as it's compressing and rarefacting. So this is one frequency, and this is a completely different frequency. So this is happening more often, this is happening less often. And we call the distance between two peaks to be a wavelength. So this is a longer wavelength than this one here, which is a shorter wavelength, okay? That's what sound is. Now, sound can actually travel through different materials beyond just air. It can travel through metal, it can travel through water at different speeds. So for air, it's 1,130 feet per second. So there are two concepts here I want everyone to learn about. The idea of frequency and amplitude. And I'm going to break that down here for a bit. So you remember here that the period of time between peaks. It's also called a period. It's called wavelength as well, so that kind of interchangeable. So we have here one frequency that's happening this often, and then we have another one here that's happening more often. So this is what would be considered a low frequency, and this would be a high frequency, right? So these periods are shorter, and they're happening more often. But what's interesting is as the frequency goes up, the pitch is higher, okay? And the lower the frequency, the lower the pitch. So the frequency is how often the sound cycles through. Amplitude is how much, in terms of volume. So if you think here that this amplitude, or if you look here, the amplitude's a bit lower, that actually signifies that it's quieter. And here amplitude is louder, and you can see that the wave is actually moving further and further up in pressure. Does that make sense? So it's pressure over time. Time is frequency, pressure is amplitude. So that's what sound is. So what happens, sound waves eventually make it to your ear, and I was saying 1,130 feet per second. In meters, it's 345 meters per second. Once it gets to your ear, the ear basically collects, this is your pinna, as they call it, basically is collecting the sound and going through the outer ear into the middle ear and the inner ear, and your brain basically does the rest. It encodes that information. Through evolution, we've actually, your brain is an amazing pattern recognition device, and we've been able to associate sounds ever since you're inside, your mom's womb. It's pretty incredible. So the range of human hearing, again, this is an important thing to know, is 20 hertz to 20 kilohertz. Now, obviously, as you get older, you don't reach the 20 kilohertz. I'm probably closer to 15 or less. Younger folks, probably way up there. So human speech range is actually between 300 hertz to 3,400 hertz. Okay, so, from the perspective of telephony, this is important to know. So that's why telephones tend to sound really low fidelity, because they're only really just focusing on this range, and all the rich higher frequencies aren't there. So you're not necessarily going to be listening to your phone and expecting like a beautiful fidelity, high fidelity experience. So this gets the job done in terms of understanding speech, okay? So let me see if I covered everything there. So let's now move on to microphone basics. Here are 3 different types of microphone elements. And it's basically how they operate, okay? Here's what's called a dynamic microphone, a condenser microphone, and a ribbon microphone. Each of these are actually quite, used in recording studios, in radio stations. You'll probably see more of these two. Ribbon microphones are actually really, really nice. Problem is they kind of got a bad rap in the early days of their development because they are very fragile. They don't handle being dropped very well. Just the elements in there are very, very susceptible to basically falling out of place. They do sound really good, and they have been used in broadcast, but they've gotten a reputation for being very sensitive, although newer ribbon microphones actually are more robust. Condenser microphones also tend to be a bit fragile. You ever dropped a condenser mic? You probably don't want to do that. The dynamic microphones they're known for being bulletproof. You'll see dynamic microphones used heavily in on stage performances, right? So if you go see a live show, they're probably using a Shure SM58, actually. So anyway, so just in general, dynamic microphones known for being robust. Condenser microphones, a little more fragile, but have a great sound as well. And ribbon microphones are, again, very good sounding microphones, but they're used a little bit less often because they're susceptible to damage. Excuse me. So here's an example of a dynamic microphone, and I'm going to kind of show here how this works. So we have the sound waves coming in and hitting. It's kind of hard to see. Sorry, it's too dark. There's actually a diaphragm on top here. And as the sound waves are pushing onto the diaphragm, it's actually causing a coil suspended near a permanent magnet to actually move. And that movement of sound in the diaphragm creates an electrical signal. Okay, and that electrical signal, we can do stuff with that, right? That's your content. So permanent magnet, moving coil, this is how dynamic microphones work. I'm going to show you how condenser microphones work. They're pretty similar, except for a few subtle changes here. First off, this is actually metallic, the diaphragm. And what ends up happening is you have a electrically charged backplate. And as this moves, okay, it's actually causing minute changes in electrical signal that's being traveling here through the wire down here. So as the sound comes in, the movement of the diaphragm actually translates to an electrical signal because of the motion of the diaphragm against an electrically charged backplate, which is the electrode here. Now, condenser microphones tend to have an actual power supply to charge this back electrode. Did you have a question? Oh, okay, sorry. So the difference, kind of going back to the other one here, there is no requirement for power. There isn't a power supply needed, whereas with condenser microphones, you need to have a power supply. And I might as well just mention it now. This power supply for a condenser is actually a voltage, and it's a precise voltage of 48 volts. We call that phantom power. Very important. So you need phantom power to charge the backplate for a condenser microphone. Phantom power. Phantom power. Yeah. Okay. So, yeah. The term analog actually is short for analogous. So the electrical signal is analogous to the actual changes in pressure from the sound waves. So it's basically, as this is moving analogous to it. So I'm going to go back to dynamic microphones. You probably recognize some of these. You've seen them in some streams possibly by other folks. This is a really popular microphone. You see a lot. Joe Rogan on his podcast uses this, and a lot of TV shows, a lot of, I should say radio shows, a lot of YouTube shows are starting to use this. Another popular one is the Sennheiser MD421, an Electro Voice RE20. Feel free to take a picture of this if you want to kind of get an idea of what some popular dynamic microphones are. The Shure SM57 is something used a lot in live sound reinforcement on a stage of a show, right? You see your favorite band, I guarantee you there's got to be one somewhere. Another one is from Rode, and there are many, many others, okay? Now, again, with the dynamic microphones, they do not need phantom power. Condenser microphones do need phantom power. And just as we explained why, because of the charged backplate. So there are two different types of condensers. There's something called electret condensers and true condensers. We're not going to necessarily get into the deep, we're not going to go into the deep dive of that. Just know that electret condensers are, let's just say they're cheaper elements. They're very robust, and they actually have improved, vastly over time. Electret condensers kind of had a bad rap in the 70s and 80s for being cheap, and not only cheap in terms of cost, but not sounding very good. That's changed. These actually sound quite good, in some cases as good as true condensers. There are some advantages to the true condensers in terms of frequency response. These don't tend to be as good on the high end. When I mean high end, the high frequencies, I was telling you the human range from 20 hertz to 20 kilohertz. These tend to go way up there. And although sometimes these are advertised as going to 20 to 20 kilohertz, they don't necessarily do it that well. But what we learned about the human voice, what frequency range is that? 300 hertz to 3,400 hertz? So as long as that's covered, and you're really focusing on just vocal speech, this will do just fine. So I'm sort of showing these because, it's good to know what the options are. And I'm going to talk a little bit about application and figuring out what microphone is for the right job, because not one microphone is good for everything. You may want to use a condenser mic for one thing and a dynamic mic for something else, and there are many other types of microphones. As you can see, I'm wearing a microphone. This actually happens to be a condenser microphone, but it's in a form factor that makes it easy for me to walk around, and we'll talk about that here in a bit. So let's see. So yeah, this is the Blue Yeti Pro. And what's cool about the Blue Yeti Pro, I just want to point out, is that it's both a USB mic and analog. So you can actually decide if you want to use it in analog. It has like the ability to just plug in as analog, or you can use it as USB. Most of the other mics I showed here, these are all analog, meaning you need to plug them into a device that I'm going to cover a little bit later to get these to work. They don't just work right off the bat. They don't have USB. So yeah, so these true condensers are, you'll see these used a lot in recording studios. They have a fantastic sound, and these are quite expensive. So just know these tend to be in the maybe $100, $200 range typically, or less. These are sometimes in the several hundreds, if not in the thousand or more category. But they have a purpose, right? So depending on what you're doing, you may want to use that versus this. So a couple of examples here. So Howard Stern actually, this is a condenser microphone that he's using here. This is from a company called Nguyen. And this one is probably $1,000 plus microphone. This one here is a dynamic microphone. So again, this is condenser, this is dynamic. And this was the Electro Voice RE20 that I was pointing at earlier. And this one's the same mic, except it's gold-plated. So yeah, it's the bling factor there. But you'll see a pattern if you start noticing like some of these YouTube videos, and you start to see what people are using. It's quite interesting. You'll see a lot of these Electro Voice RE20s. And for a good reason. They are a very good mic. They handle, this is one of the characteristics of the dynamic microphones is they're very robust and they take a beating, but they also do a very good job on voice and speech, okay? And so that's why these have sort of become very reliable, and they have a great sound and people like using them. So these are photos of other personalities. You'll see here, this is the SM7B. Again, this is from a Joe Rogan podcast. This is the guest wearing or having this particular microphone. PewDiePie here, I know you can't really see here. This is an AKG microphone. This is a condenser microphone. So this is dynamic, this is condenser. And here's another RE20 that I was pointing at earlier. So the majority of the time you'll see typically dynamic microphones, but people also do use condenser mics. So again, just depends on your preference. Now, I want to point this out to see if anyone can pick up what mics are actually being used here. This is actually a side view of an RE20, and this one is an example of a ribbon mic that Larry King uses. But these are props. They're actually not being used. It's kind of hard to see here, but he's got a clip-on mic. Yeah, David Letterman. Same with Mr. Larry King here. So radio kind of has this image of people having a microphone on the desk. You see it on, a lot of late-night TV shows, whether it's Jimmy Kimmel or maybe he doesn't have one, but I know like Conan has one and others have it. So there, it kind of has that radio broadcast look. But a lot of times, if they're, doing something, behind the desk, or they're leaning back in their chair and they're not right in front of a microphone, or they're running around doing something crazy with the guests, as you see sometimes some shenanigans happen on the stage, having something like this actually makes more sense. So again, I want you all to sort of think about the idea of using something like what we call here is a lavalier mic, is the term, which is what I'm wearing here. And a lot of times they're wireless, battery operated, so you have a wire going to a transmitter, and it's being received by a receiver, and it's using radio waves. And the range is really good on these. So again, it's just another option. These are battery powered. I have one here that's actually not battery powered, that just plugs in directly as a wire to my USB interface, which I'm going to talk about here a little later. So there are wireless varieties and wired varieties. So again, just good to know the different options out there. All kinds of different mics out there for different use, right? We've seen the more like desk or stand mics. There are, headset mics. as you know, in gaming headsets. They'll typically use microphones. Here's a parabolic dish. I've actually used to use these for recording motorcycles because a lot of times I couldn't mount a microphone on the bike because it would fall off or whatever, or, you know. So I would actually follow the rider with a parabolic dish. I did MX Unleashed. It's a video game that came out, maybe some of you recall, but it was in the mid-2000s. We did a lot of the sound recordings of the motocross bikes with a parabolic dish. So they come handy. There's boundary element microphones. They're called BEM mics. And these are great for like a stage. So you could just place it on the floor of a stage or in the middle of a conference room, and it picks up sound. It basically bounces off of here into the microphone element. All kinds of different microphones for different purposes. So I just kind of want to introduce this idea that, you know, one microphone may not be suitable for all applications, and that you should definitely be aware that there are different microphones for different things. So, so getting back to the dynamics, dynamic microphone versus condensers, this is very important. I've done it myself where I didn't know if a microphone was condenser or dynamic, how you should actually point the sound, the microphone to the source of the sound of where it's coming from. In the case of a dynamic microphone, the sound actually needs to come basically directly in front, on top, in this case, of the, if you're holding it like this, it needs to come from on top, versus the condenser microphone, if you're holding it basically perpendicular to your face. So keep that in mind, that's how these work. So microphone placement is also important. Because if you start to speak this way against the dynamic microphone, it may not pick up as well. So that's important. Now I'm going to show something here that kind of gives you an idea of pickup patterns, or also called polar patterns. So this is actually misspelled because I didn't type this. This was a web image. The term cardioid refers to a directional microphone, which means the pickup pattern is picking up this shape, this in front of the microphone. Okay, it kind of looks like an upside down heart. And this one here is omnidirectional, which means that the microphone sound is picked up from all around. This is important because if you're in a situation where you want the sound to only be picked up in front and not the back, or vice versa, or all around, versus omnidirectional. And omnidirectional may be very useful in some applications where, let's say, you have a group around one microphone. That might be very helpful. Or if you want to pick up a particular sound in one direction, then you want to use a cardioid microphone. There are other polar patterns. So omnidirectional we talked about, cardioid. There's something called supercardioid, which means that it's slightly, you can't really tell in this picture, but slightly more directional in the front. Hypercardioid's even more directional in the front, but you notice you get some lobing in the back here. That means it's picking up some sound from the back as well. Not too much, but enough for you to keep in mind. So have you ever been on a stage or been near a stage where you notice, let's say you have a singer, they'll have a microphone. What's directly behind on the floor is usually a speaker. And that speaker is so that the singer can hear themselves. So if you notice, the speaker is placed in such a way where, in the case of cardioid, so SM57, which I mentioned earlier, has a cardioid pattern. And it's rejecting the sound from the back. So that's important because that reduces feedback. So just to kind of add some perspective to that. So polar patterns are really important in helping determine which microphone you should use. Bidirectional is actually very cool. I've been in recording studio situations where, if, let's say you have a duet, you have two singers, one could be on either side of the microphone, and it picks up both on either side. So that's pretty handy with condenser microphones. A lot of times condenser microphones are open on each side, so you can have actually one person on one side and one person on another. A lot of times the condenser microphones actually have the ability to switch patterns. So you can, switch to a bidirectional pattern if you want, or they also call it a figure eight. So a lot of these microphones allow you to switch from like cardioid to omni to bidirectional. So for the condenser microphones, that's kind of handy. So yeah. Okay, this is very important. Mic filters. I can't stress this enough. Oftentimes what ends up happening, and maybe if you've done it in your broadcaster, you're aware of this issue, certain consonants and letters, like P or T or B, just try this right now. I know it's kind of silly, but put like your hand in front of your mouth and just speak normally, and then say like P. Just use the word, or use the letter P. You'll feel a gust of air coming out of your, touching your hand. That right there can overload a microphone. Yeah.
What are those sounds called?
Plosives. Yeah, they're called plosives. Not explosives, plosives. Like without the X part, yeah, plosives. So plosives can be a problem. So a lot of times you'll see this one actually, this pop filter, we call them pop filters, it's basically a material that's stretched out, and it's a screen, and it helps sort of block that gust of air. This one actually attaches on the microphone itself, and this particular one I think attaches to an RE20. This one attaches to a mic stand. Now, I want to kind of talk about, obviously this can kind of look bad if you have a camera in front of you, and so you got to kind of deal with that. I'm going to kind of show how other people deal with it. Another mic filter is a windscreen. These are pretty helpful too, and these are actually, it's kind of an extreme windscreen. I've actually done recordings out in the, doing sound recording for back when I was working on video games. A lot of times we'd have to get really extreme with these because we get excessive wind noise. And they lovingly call these dead cats. I know it's a terrible name, but yeah, that's just the industry term for that. It's unofficial. But yeah, it's just basically a very thick windscreen. It can be very effective in knocking out wind, but that comes at a trade-off because you're also deadening the high frequencies because you're absorbing a lot of the high frequencies. So you got to keep that in mind when you're recording, that you're eliminating a lot of high frequency content. That may be desirable, or you may have to compensate for that in post-production. So again, these windscreens can also be helpful. This type here, I think this is on a blue Yeti. It can also, I guess, be pretty effective against pops, but you'll have to try it out and see. Or see what others are using that with success. So microphone placement. I'm showing this particular one for a reason. You can see here, like, it's being aimed at the person's voice, and the pop filter, it doesn't necessarily, it's actually not too bad in terms of how it stands out, right? So it's a nice way to mitigate that instead of having a huge thing just blocking your face. This one here, Joe Rogan again, he's using, you can't tell here, but it's actually got a windscreen on top of it. So that one, helps to deal with his plosives. So they can be very effective, pop filters and windscreens for dealing with that gust of air from plosives. Any questions? Or move on? It depends. It really depends.
Hello? Oh,
yeah,
hi.
I hear you.
Do we need any kind of a pot filter with the Go XLR?
You need it on that one.
Well, when you use the word penetration as your primary thing, so it's very important.
You may need it, and it depends how close your microphone is. I'm going to get into a little bit of ideal placement of microphones to get an ideal level. But if you are experiencing plosives in your recording, then certainly you want to use a pop filter. Yeah. I would actually to kind of, if you don't mind, I'm just going to follow up on that. That's why, honestly, I would maybe consider using, that's the thing about condensers. Condensers are actually very, very sensitive to wind and those types of noises. You could mitigate it with a pop filter, but that's actually why some people consider using a dynamic microphone. Although in this case, this is a dynamic microphone, and he's also got a pop filter on it. So I don't want to say like, oh yeah, get a dynamic microphone, you'll be fine. Well, it depends, right? So absolutely, yeah, you're gonna have to experiment. It's unique to the individual for sure. Yeah.
Are there built-in pop filters, and how effective are those?
There are microphones that have built-in pop filters. It depends. You can always add a pop filter on top of a pop filter. I've seen it happen. In some extreme cases. Yeah. So, yeah.
Just to provide some context to the question that was posed earlier, the Go XLR is one example of a audio interface that will be covered later on in this presentation. Just
Yeah,
a-
yeah, I'll be
just a heads
talking
up.
about the Go XLR a little bit later. Yeah, yeah. So I'm going to touch on this subject because some people are actually doing 3D or using 3D microphones. So the 3D microphones, these two examples here are what are called binaural microphones. Binaural literally means 2 ears, just 2 ears. And kind of an interesting phenomenon that happens with microphones that use synthetic ears is that you can actually simulate human hearing that way. And essentially you have a microphone element kind of near where the ear canal would be. Why is this cool? Because you can capture a very immersive 3D sound experience with these microphones. Anyone heard of ASMR? Right? This is, everyone laughs. I mean, it's a thing. I get asked about it all the time. These microphones from 3D.io are actually very popular for that. This Neumann KU100, bit extreme. This is like a $10,000 microphone, but it's a very, very, very good microphone. Zoom actually came out with, this is not a binaural microphone, but it's an ambisonic microphone. First order ambisonic. I was speaking with someone earlier. I forget. Was it you? Yeah. This is very, very reasonably priced. It's like $300. I don't know how effective it is with ASMR, so we'd be curious to see how some people are using that. This is my day job. I actually work for a company that designs a 64 microphone element array. So this is 64 microphones around a sphere. And we use this actually for noise and vibration analysis for automotives and wind tunnel tests. So we can actually do some very interesting things with this many microphones to pick out sounds in space, in 3D space. And these also have cameras all around, so we can actually attach an Oculus Rift and actually tell a presence through this thing. It's kind of cool. Yeah. Sells for about $60,000 to $100,000, but it's a specialized device. But it does capture in 3D, so it's pretty cool. So ASMR is autonomous sensory meridian response, in case anybody was curious what ASMR means. And it's basically a phenomenon that happens with humans where you feel relaxation and calmness from certain sounds. A great example would be, you ever been to the theater, and I've noticed it very recently, where they have a Coca-Cola ad, and it's like really popping and sizzling and stuff. That's an example of like what ASMR does, and it triggers a response. It really does, like makes you thirsty, you want to go buy one. So that's, I mean, they've been using it for years, that sort of that response. So yeah. So 3D microphones do have a place, and a lot of people are now getting into live streaming on Twitch and with YouTube with that, and doing recordings as well. So let me see here. So any questions up until this point? I've covered a little bit about the history of broadcasts. I know it's a bit maybe boring, but I feel it's important to kind of know where this stuff came from. Yeah. Oh, the microphone. It's because we're recording too, so it's helpful for that.
In terms of use of dynamic condenser and ribbon microphones, is there a benefit to either of those? Would there be a reason, oh, I don't want to use a dynamic, or oh no, I don't want to use a condenser, this one's better than the other?
Right. I will tell you from like being in recording studios, a lot of times what ends up happening for recording instruments, there are cases where you want to do one or the other. Kick drums seem to, really respond well with dynamic microphones. So a lot of times you'll find a dynamic microphone right on the kick because you're getting that gust of air, and it's just something, and it handles the pressure really well. Condenser microphones typically used for recording, let's say, a guitar or instruments, or even the human voice. I mean, singers a lot of times use condenser microphones. Now, from the context of broadcasting, I've noticed that the majority, so this is kind of not an exact number, I would say like 70% of the time you'll see, just looking on YouTube what like some of the personalities are using, most of the time are dynamic. And I think it's a combination of tonality, tone, from the tone of how it works with that individual's voice. Also, the ability to handle plosives. But again, you can use pop filters, so you could use that as well. They tend to be more robust. They're not as sensitive and finicky to being dropped or that sort of thing. That's a big one, actually. So yeah. I don't know if that answers your question. I mean, it kind of depends, but I don't want to necessarily say for certain because, there are people that record guitars through an amp with a dynamic mic or condenser. So it's like I can't say one or the other,
And so, in terms of pop filters, there are, wind shields and so on. So how do you know which one would be right for you, or do you just have to try both?
Well, I would say that the pop filter is probably more effective, and one of the reasons why it's effective is it actually adds more distance, right? Because if you notice the way they're sort of set up is that it basically creates a distance just from the virtue of how it mounts, so that it adds a little bit of protection there. But also, I mean, in terms of material, they're really not that different from a windscreen if you look at it. Actually, the windscreens can actually be very effective because they tend to be a thicker foam. If you look at the pop filter, they're almost like I don't know what that material is. It's almost like a sheer.
It's like a thin fabric.
Yeah, thin fabric. Yeah, a lot of times it could be double layered or whatever. You can actually sometimes see through. With the windsocks, I mean, they're all over the place. I've seen thin ones. I've seen really thick ones. So it's kind of all over the road. Yeah.
Thank you.
I hope that helps. Yeah. Hexor actually had a question first back there.
Hey, it was more of a follow-up on the dynamic versus condenser microphone thing. In my experience, and correct me if I'm wrong, the condenser microphone you can have a little bit further away from you, and it's going to pick up more sound in the room too. So if you have a lot of background noise in terms of broadcasting, it's going to pick it up, especially if you have mechanical keyboards, that kind of stuff, you run into that issue. Whereas the dynamic mic is like you have to have it like right next to your face.
Right.
So you have to determine if you want the microphone in your face or if you're willing to have it, a little bit back off your screen and you don't want it to be shown on screen.
Yeah, you're right. That is a trade-off because a lot of times, too, condensers, you have to be careful because they are available in multiple patterns. So you can get omnidirectional or cardioid. Some of them allow you to do both. So as Hexor said, if you have a microphone that's, let's say a condenser microphone that's placed at a distance and it's omnidirectional, that's bad. That's picking up everything around that microphone, whether you want it or not. That's why you typically want it to be more directional and as cardioid as possible to get to where the sound source is. That's what this is about. You want it to pick up what pertinent sound that you want. So that I would say that's, rather than focus on condenser versus dynamic, I would focus on directionality. So in the case of unidirectional or omnidirectional, that's what I would focus on. Yeah.
I'm glad you brought that up because that is definitely more important. And in one particular consideration, and that is most streamers are at various points, if not all the time, gaming.
Yeah.
Which means they've got their game audio coming through their headphones,
right.
or a lot of people just play it out of the speakers in front of them.
Right.
But they're also feeding that audio directly into OBS. So now you have
right.
two audio sources, but they're not in sync.
Yeah.
You're going to get either delay or phasing.
Absolutely.
So I thought I'd let you.
And that's why directionality is important. So if you got speakers, you want to make sure that you have the right kind of microphone that's not picking up that speaker sound.
Because that's stuff.
Yeah. I mean, you could do it. You could do it because, I mean, again, you see it in live concerts. They have, monitors on the stage pointed at the microphone. The microphone is rejecting it, right? So there are ways to mitigate that. That's why a cardioid microphone in that particular instance would be a good idea. Yeah. Did you have a question?
The directionality, can you change that, or do you have to buy the microphone?
So in the case of condenser microphones, you have to look out for microphones that offer different patterns. Sometimes the only available option for a particular microphone is cardioid, or the only option is omnidirectional. And multi-pattern microphones do exist. A lot of times, though, with the dynamic microphones, they're typically only directional. They're typically only cardioid most of the time. Yeah.
How do you find out? Do you look it up on the internet or something?
Yeah.
I have a snowball, but I don't know anything about it. So.
Yeah, snowball is not. So you just, when you're shopping for microphones, this is why I'm doing this, partly because now you sort of know what to look for. Look for directionality, look for whether it's omnidirectional, whether you want unidirectional or cardioid. So you kind of have to know coming in, oh, what is my goal? What do I need? And what's the right mic for it? That's basically what you want to be able to do. And I see this a lot. And so-and-so is using a Blue Yeti or so-and-so is using a snowball. That's not the way we should, again, I mean, if you don't know any better, hey, it's not your fault. But that's why we do this. So it's like you can now be aware of like, okay, it's not about what so-and-so is using, it's about what's right for me. Yeah. Great questions. I really appreciate it, and I hope I answered them. And thanks for a lot of the add-on material. I think that was great. So let's see how we're doing on time. Okay, we got about 48 minutes. Are you all in the mood for a break, or can we continue? You want to keep going, or you need a break? Keep going. Okay, we'll keep going. Analog versus digital. So once sound waves become electrical impulses, we can do stuff with them. So in the case of analog, we can manipulate them electrically. So whether you want to record or broadcast, it has to exist in that domain. It has to be at least analog before we can do anything with it. Now, obviously, in order to stream on Twitch, YouTube, whatever you're using, it has to be converted to digital, right? So I was saying earlier, I was mentioning, let's say, some of those dynamic microphones that are just analog. You can't just plug it directly in your computer. There's no, that doesn't work. So there's got to be another device that interfaces with it. I'm going to cover that here. So let's talk about the process of analog to digital conversion and the reciprocal of that, digital analog conversion. So analog digital conversion literally converts those continuous electrical signals into discrete binary data, into zeros and ones. So it's a process of taking those waves, amplitude and frequency, and converting it into ones and zeros. The opposite happens with digital to analog. You're converting discrete binary data, I should say, this is wrong, into continuous electrical signals. So what does that look like? So going to analog to digital conversion, we're literally taking snapshots of a continuous signal. So this is happening at a particular rate that we call samples. In this case, samples per second. And it's measured in hertz, Hz that you'll see. So, so each of these samples represent a particular amount of data. In this case, it's represented as a number, let's say from 0 to 15 in terms of its amplitude, right? And its frequency is basically represented in that as well. So the amplitude and frequency are basically both captured by as part of the analog to digital process. And typically these, each sample, okay, so one sample will consist of either 16 bits of data or 24 bits of data. So CD quality, if you've heard the term CD quality, is actually a very specific metric. It's 44,100 samples per second, and each sample is 16 bits long, or word length is 16 bits. Okay, and there are other, other formats, if you will. There's 24-bit, and there's even 32-bit, and more. So, but the 16-bit is typically what you see most of the time, and you're seeing more and more of these as well. So, let me see if I covered everything here. All right. So, the more snapshots, the better the fidelity, okay? So what ends up happening is you'll see here that this wave is represented as kind of jaggedy, right? And it becomes less jaggedy as you take more samples. Did you have a question, Ty? Yeah.
You used the word fidelity. Could you elaborate on that?
Well, fidelity is, can be a bit subjective, but I'll just say that there is a difference in terms of sonic quality when you have higher sample rates versus lower sample rates. And you know, it's funny, when I used to develop game audio content, back in the day, I was actually one of the first consoles I worked on was the PS2. PS2 had 2 megabytes of sound memory. 2 megabytes of sound memory. Not 2 gigabytes, 2 megabytes. So the things that we had to do. So there's sort of a scientific principle called Nyquist theorem, and I'm going to get into it. But essentially, if you know the sound is a certain frequency or has a certain top frequency, you can get away with a lower sample rate than a higher sample rate. It can be somewhat of a waste by using high sample rates for no reason if resources are limited. So what you'll find is, at a bare minimum, okay, just kind of carry on the idea of fidelity. The range of human hearing is 20 hertz to 20 kilohertz, right? So if I have that's one of the reasons why we use 44,000, because it's over double what the range of human hearing is. And the reason why it has to be double is because you need to be able to sample the top and the bottom of a wave. So that's why it's double, and that's Nyquist theorem. So that's why you need, basically for decent fidelity, it's got to be at least 44,100, as it's been deemed by academics and scientists. That's sort of a reasonable number. And there are higher. And there's a bit of debate out there whether we need to go higher or not, but I don't want to go into that. It's a rabbit hole. So does that answer your question? Yeah, cool. So yeah, high fidelity at a bare minimum is 44,100 samples per second, or 44.1 kilohertz. That's 16 bits, because it covers the range of human hearing. So now let's break this down. So the analog to digital process, ADC, and as you can see here, it's basically converted into bits of data. And the reverse happens. So that's what it actually looks like in your computer, right? So this wave is actually that, right? But if I want to hear that, I'm not going to be able to hear that. It needs to be converted back. So there's actually a filter that basically takes it and reconstructs the original wave based on this. And basically what it's doing is interpolating. And I don't know if you know what interpolation is. It's basically like a computer algorithm that kind of guesses and smooths out everything. So interpolation filters have gotten a lot better over the years. The very first CD systems were terrible. I mean, people, you know, the very first CD systems that kind of had they were kind of notorious for sounding bad. But over time, they've gotten a lot better. So that's how we basically go back to analog. Analog to digital conversion, and then digital to analog conversion using a filter that does some interpolation to get you back to an analog waveform. And this is what we need in order to hear it. Because we can't hear digital directly. I mean, we don't. I know that Elon Musk is working on a direct-to-brain interface, but that's not quite there yet. Maybe, I don't know. Might happen. Who knows? Who knows? Yeah, I don't know if the sample rate's high enough, it might be fine. But so, yeah, cool. Any questions on this process? Does it make sense? Okay, cool. Thank you. So that went a lot better than I anticipated. That's cool. So let's now move beyond the analog to digital conversation and get into some of the other hardware that kind of makes all this work. So preamplifiers, audio interfaces are what I'm going to touch on. Now, this is basically an example of you have a wave, in this case, that's unamplified. Let's say it's coming directly out of your microphone. So whether it's a condenser microphone or a dynamic microphone, if you were to look at the raw analog signal coming out of the microphone, it's actually very, very, very low in terms of its output, in terms of voltage and current, and overall, it's just not amplified. So what you're going to have to do to actually make it usable is to boost that signal up, amplify it. That's why we use microphone preamplifiers. And that's a necessary device if you're working with some of these microphones that actually have analog connections. You need to boost the signal. All the microphones that you see here, all these connections coming into this device, they actually have microphone preamplifiers in them. Yeah. And even this desktop PC actually has a microphone preamplifier. You've seen the pink jacks on the back of a PC? That's got a tiny preamplifier inside there to boost the signal out of the microphone that you're using either on a headset or stand mic or whatever. They tend to be kind of crappy though, the ones on the PC, just saying. So, just keep that in mind. Yeah, did you have a question?
Is the unamplified wave or sound wave, is that noted or known as line level, or is it something different?
No, line level that's a different concept. So line level refers to the voltage of the interface. So there are differences in let's say, I don't know if you're familiar with RCA jacks versus XLR jacks. They operate at actually at different impedances and voltage. Well, actually, there is mic level and line level, right? So actually, I'm sorry, I had to kind of think about that for a second. I would say the amplified one is line level. That is correct. Yeah, so I would make that assumption that if your mic level is a much lower voltage, line level assumes that it's boosted and amplified. So yeah, to answer your question, that's actually right. Sorry about that. Yeah. Greg, he's going to follow up.
So I think that the original question was whether the signal coming out of the mic was line level or not.
Oh, no,
Right. It's
it's not. I apologize, I misunderstood. Yeah,
Is
it's
that
not
what-
considered, is that what you're asking? Coming out directly out of the microphone? Is not line level, no. It's
So-
mic level.
Yeah, that would be what we
Yeah.
call mic level. And to give you an example, actually in practice of knowing your mic level versus your line level, we're making a direct recording of the microphones that we're using today for the lecture, and that's going into my stereo recorder here. So I've got the microphones that are in the recorder, but you see how I have this XLR cable going into the audio interface. These jacks on this particular recording device are meant for microphone connections, XLR microphone connections. But the output of the mixer is actually sending a line level signal to this recorder because Mike and I, we've already amplified this microphone at the mic preamp over there. So one of the things I actually had to be real careful with this recorder is because it's expecting a mic signal at the input and not a line level signal, I actually use a pad
There you go.
at the input right here to knock it down 20 dB. And that's one of those little tricks that you can use is if your microphone preamp has a pad on it, you can, usually what a pad does is it'll attenuate or lower the level.
That's correct, yeah.
At the input down 20 dB. And that effectively makes your mic input behave like a line level input because of course, as we were talking about, the mic level is lower and then the line level is much higher. So
Right.
I'll let.
No, that's thank you for that. Yeah. And thank you for asking, it was a good question. Well, I'm gonna, let's see if I could get through to the next thing here. Let me just finish this one slide and then we'll go ahead and take a break if that's okay with everybody. I appreciate it. So here's kind of a very simple diagram of how this works. So in the case of a microphone that has an analog output, you need to go into a microphone preamp. And from the preamp, you need to go in your audio interface in order to go into the computer because you can't go directly this way, right? Can't just plug the microphone directly into the computer. So it has to go to a preamp, and from the preamp into an audio interface, and that audio interface is what's doing the analog to digital conversion and back. So analog to digital, digital analog through, in this case, USB. Now, there are devices that actually, and the reason why I kind of put this around one, because there are combo devices that have microphone preamps and the audio interface in the same box. And that's very, very handy. You can think of it as a combo interface. So, but if you want, you can have a separate preamp. In recording studios, you have like very boutique preamplifiers. They're like, oh, I got to plug in this Avalon preamplifier that costs like $3,000. And then you have a separate interface that costs like $10,000, and there's reasons for that. And so sometimes you want to separate that for a particular sound, but for most of the stuff we're talking about here, a combo interface will work just fine. So that's how you get an analog signal into the computer and back to the headphone. So, and it's kind of hard to see here with the colors, but the analog is black and the red is the digital data. Yeah.
There are some audio interfaces that.
Oh, yeah. Oh.
So just a point of reference, there are some audio interfaces that combine an effects processor too.
Sure, yeah. Yeah.
Because, I mean, there was one model of audio interface that was mentioned earlier during the presentation by an audience member that combines both preamp, effects.
Has a whole bunch of other stuff, correct. Yeah.
And shiny bells and whistles.
Absolutely. Yeah, and that could be very handy. Very, very handy. Yeah, so as I promised, after this slide, we'll take a break, and then we'll kind of continue on the discussion of cool gadgets and gear. Unless you had a question? Did you have a question?
Do some things already come with this in it? Do like some microphones already come with that in it? Because it sounds like you said that it has to be done?
No, I'm talking about the specific microphones that are analog.
Oh, only analog
There
microphones
are
need
microphones that basically have, and I should maybe you can add a box around this, so all three of these. So there are microphones that actually act as a preamp and have an audio interface. Yeah, that's a very good point.
But they're not analog?
Well, they're analog because that's how sound works.
Okay.
But the conversion is happening,
Already in
and
the
the
microphone.
preamplifier and the interface is happening in here. Does that make sense?
Yeah, yeah, yeah.
Oh, you definitely need to go from sound waves to digital somehow, but it's just got it inside. You just can't see it. Yeah, that's a good point. Thank you for bringing that up. Yeah, I think the Blue Yeti, I think, acts as an audio interface. Yeah, 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 yeah. Cool. Break time. Thank you.
Oh, shoot.
All right, everybody.
Sonic's next year.
Let's get back to it. So, just some examples of some audio interfaces. And these interfaces have the preamps built in to the audio interface. So it's a combo. Yeah, Focusrite is a well-known brand, Mackie, PreSonus. These are just examples. There are many, 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 many more. Yeah.
Quick question. These are
Oh, microphone. Yeah.
these are audio boxes?
So it is a combo preamplifier audio interface. We typically nowadays, when you think of an audio interface, it has the preamps built in. It's generally what it's kind of accepted. Yeah. Any other questions? Oh. So, excuse me here. So XLR. Anyone know, by the way, what XLR stands for? Anyone? Extendable line return. Yeah. So, I'm sorry, external line return. I said extendable. So it's a 3-pin connector. And what's great about it is it basically has a separate ground and then positive and negative, right? So what's really great about XLR cables are the fact that they are what are called balanced cables, and they can run for a long distance. I mean, I don't know the exact number. I think it's well over 100 feet. And reduce noise. And without getting into specifics of the wiring, one of the cool things about what an XLR cable does and how it's able to handle long runs without any interference, I mean, there are radio waves, RFI interference, and what ends up happening is if the RFI interference gets into the cable, what ends up happening is the audio is basically has the ability on the interfaces side, so whatever you're connecting to has the ability to basically these things are, if a signal, let's say you got an RF frequency that comes in, there are strands of cables inside for both the Jack 1, Jack 2, and Jack 3. And basically that noise is going to be in phase with all the strands of cable. So the way this is designed is that as it's traveling through, it basically puts everything out of phase, and then all the noise comes in is in phase. And then once it connects to the receiving end, it's put back in phase, the audio signal is back in phase, and the noise is removed out because it's out of phase. I know it's kind of confusing, but it's called common mode rejection is the principle behind how XLRs work. And the common mode rejection is what makes it great for eliminating radio frequency interference. So that's why you're able to have these really long runs. I mean, you know, they use these on stages. You know, you'll have in a big live concert, you'll have a front of house mixer, you know, where the person is sitting in the middle of the theater or venue, and they have huge long runs into the stage, and you know, they use this method to be able to reduce interference from the cable. So XLRs are really great in that, you know, they're very robust. They eliminate RFI, and the other kind of the gold standard for connecting with these higher end professional microphones. Yeah, for both condenser and dynamic microphones. Again, this is an analog connection. In this particular case, it is analog. Yeah. Any questions about XLRs? Okay. So let's see. So I want to talk about dynamic range. So we now know what a sound wave looks like when it's captured in the digital domain and is in your computer. So what ends up happening is the amplitude, right? We talked about how much pressure, and if it was in the realm of, in the analog realm of sound in air, this is higher pressure. If this was in air, then this would be lower pressure, right? But now it's converted into a wave, and the wave is now captured digitally, and these are basically ones and zeros. But you still want to make sure that you're getting enough of a signal. And the reason why this is important is sometimes when you have the sound and it's too low, you know, it's basically can be difficult to hear on the other end. So I don't know how many streams you've seen, or you know, maybe when someone doesn't have a good audio setup, where you'll hear that the voice is basically very, very, very low in relation to all the other environment, you know, noise or other things that are happening in the background, and that's not what you want. So here's a very important slide for us to learn about. What you want to do is maximize this range. It's called dynamic range. So what we want to do is make sure that the sound is basically not too low, not too close to what's called the noise floor, and not so high that you're getting into the realm of distortion and clipping. Because distortion and clipping literally sounds like the sound is starting to cut off. It's a very, very bad sound. Digital clipping is basically like, you know, cutting off audio, and it causes a really bad distortion. That's one of the bad things about working in digital, is when you reach distortion in clipping, it's like a horrible sound. It's just literally like, you know, it's just really, really bad. You don't want that on, you don't want the audience to perceive that on their end. So what you want to do is be able to work within this range. And that's why we tend to like to work with and use metering. So, you know, I don't know, people here are using programs like OBS or other programs. You can actually see the audio meters. It basically gives you like green, yellow, and then red. Once you hit the red, that's kind of a danger zone, and the red can actually start to get into clipping. So you want to make sure that you're you know, loud enough to make sure that and I'll show a demonstration a little bit later that'll show an example of that. But you basically want to make sure that the audio is in this range, and typically if it's your voice, you got to test speaking and talking into the microphone in such a way where you know, you maybe experiment with, hey, I'm speaking loudly versus speaking softly, and see when you speak loudly, you're getting into this zone. Or if you're distorting the clipping, and if you are, you need to turn it down a little bit. So again, the basic principle here is we want to maximize the dynamic range, which basically also increases signal to noise ratio, which means that we're pushing the sound in such a way where it's far away enough from the noise floor that it actually sounds very clean and without any noise in the background. When I mean noise, I'm not talking about noise from the environment, like what the microphone is picking up. The actual electronics of the microphone and your audio interface and stuff, they also have a self-noise. But today, modern electronics are so good that this noise floor is really, really low. But as soon as you introduce a microphone into the equation, I don't care how quiet a room is, the noise floor is going to be well above what the electronics are. So, I mean, you can have a really quiet apartment, but if you really, really sit down and listen, there's probably air-conditioned noise, even though it's really faint, or something like going on, a refrigerator hum or whatever. And that's basically creating its own noise floor. So you got to be wary of that. But if your audio, your speech audio, whatever you're doing in your broadcast is high enough, this stuff just will not even factor in. So just keep that in mind. Does that make sense? Yeah, you want to maximize dynamic range, signal and noise. It's very, very important. Okay. So yeah, we've gotten everything into the computer, and so now for the fun stuff. So now we're going to talk about, I think is a very important topic of, mitigating ambient noise and why this is an issue. And I kind of touched upon earlier that, most rooms, just if you, even what you think is a very quiet room still has something in the background, whether it's an HVAC system, heating, whatever, refrigerator. That's why recording studios have, special studio rooms that are built to actually eliminate noise. In fact, a lot of recording studios actually have specially built floors that are literally, it's a room within a room. That's the extent they go to actually eliminate noise. What ends up happening is the floor is lifted, and you call them floating floors. And the floors are lifted either on rubber pucks or some mechanism that actually has some kind of, so if there's, the foundation has some noise or vibration from a garbage truck coming by or something, it'll actually like eliminate that noise or the transference of those vibrations into the inner room, if you will. So that's the extent that they go, and they're very, very expensive, as you can imagine, to build. Most of us don't have this, right? We don't have this kind of capability, we don't, at least in most cases. So, so I want to talk a little bit about the importance of using materials to mitigate noise issues. And so when we're talking about noise, there's the ambient noise, the noise of things in the room that are humming or, from the air conditioning or whatever, but also just the very fact of, even the sound of my voice now in this room, you can hear me echoing all over the place. And that's because the design of this room, no offense to the people who built this, the acoustics are not very complementary to this type of sound bouncing around the room. So what ends up happening is that echoing that you're hearing is not something you really want to hear in a broadcast. Now, probably what will end up happening is if we were to record this, I'd imagine the sound of my voice will be picked up more than the echoes. We'll have to, I haven't tested it to see, but that's what you want to kind of keep in mind. So what a lot of streamers are doing and broadcasters, even in radio, they'll have rooms that actually have absorptive foam on the walls. And what that does is it reduces reflections and the echoes that happen inside of the room. So if your voice tends to be echoey in a room, you should look at placing these on the wall. And you want to do it in such a way where the entire room isn't covered in foam. That's a bit overkill. You don't necessarily need to do that. Sometimes just even placing furniture in a certain way could help mitigate noise. But placing some absorptive foam on bare walls, and you don't have to cover the whole wall, but just like a good portion of the wall will help reduce some of that. Yeah.
So I have absorptive foam that I have throughout my streaming room, and
Covered from floor to ceiling?
no, not entirely, but for the most part, yes.
Okay.
And my question is, I know that it helps and I know what it does, but I don't understand it. What is that? Does it absorb the sound into them? Why is it pumped like that or
It does.
pointed like that?
So what ends up happening is the foam absorbs a particular range of frequencies, right? Because as we know, the range of human hearing, 20 hertz to 20 kilohertz, that's a broad spectrum. There's lows and there's mids and there's highs, high frequencies. So really with the foam, it's more effective on the high frequencies. Now, if I were to clap, you know, that high frequency ringing, that very, very high part of that, that's where the foam would really help mitigate that, right? As far as the lower frequencies, the foam isn't really gonna do jack squat for that. So if you have like issues with like vibration from, let's say, a garbage truck rolling down the street, the foam ain't gonna do anything. It's just not.
You're gonna need to lift the floor up for that.
Well, yeah, no, that's it. Just gonna move at that point, you know. It's cheaper to move, you know. So no, but yeah. So that's a great question. So what frequencies is the foam really effective? It's probably in the few thousand hertz on up. Yeah. Yes.
For me, foam is very effective because I really like foam as a female gamer because I get excited and intense, and that will cap out the mic. If I don't have foam, word is that it just bounces right back to the mic. And
oh, I see.
it's so
right.
annoying
Yeah.
because I'm loud, and I don't know if it's better.
So
for
it helps
male
in
or
your
female,
case.
but as a female and my voice being as high as it is fantastic.
Where do you have it? Where is the foam placed?
Right now, at our current location, we don't have foam. We have curtains, but we're looking at getting foam. More
Okay,
foam.
curtains.
I miss my foam.
Yeah, curtains are a good choice too. If you have like windows and you don't have curtains on, or you have blinds, maybe adding a curtain would help. I'm just in general, just a general statement that helps because it has an absorptive effect because of the fabric. Yeah. Any other questions? Oh yeah.
Also, another really advanced technique is running a curtain along the ceiling.
Mm-hmm.
So
that's a good idea.
Yeah, many years ago, I worked in a venue that was one of the most acoustically perfect venues.
Oh wow!
And what they did was the floors were actually lifted above, so there was like a void above the actual floor.
Mm-hmm.
Appropriate treatments on the walls, and a really sick-looking curtain on the top.
You know, there is another tool other than absorptive foam that, you know what, I don't have it here, I apologize. There's something called a diffuser, or just this concept of diffusion. So there's two principles that help deal with noise. You can either absorb the energy or you can disperse it, diffuse it. And actually, if I go back here, actually this is what I want to show you. These are actually mathematically, they're built in a mathematical way, and it's actually, if I remember correctly, this is a parabolic function. And it's kind of random, but it actually has a pattern to it. And this right here scatters sound. Doesn't absorb, scatters. And Kenley, what I was going to say is I've seen studios that actually have these on the ceilings. So if any sound bounces up, it gets diffused on the top as well. But the curtain idea or hanging something on the top is cheaper because diffusers are
exactly.
expensive.
Yeah, one of the sub venues in this space that I had was had wall tiles that retracted it.
Oh wow, yeah, that's pretty cool.
It's a very expensive venue. It was very expensive.
Yeah,
so
these aren't cheap, but they're very effective. They look cool too. But expensive.
Expensive art.
Yeah, expensive art. Yeah. I did see a company in Europe. I think they're in Sweden. They make these in really awesome colors, like purple and blue and stuff, and people are like using them in their apartments to as decorations. So it's pretty cool. In their high-end loft or whatever.
If you have woodworking gear and a lot of time on your hands.
You could do it, yeah. There are how-to videos on how to do this. Yeah, absolutely. Yeah, I've looked at them. It's kind of cool to nerd out and stuff like that. Okay, so noise. Still got noise. So dynamics processors to the rescues. Now this is dynamics from the standpoint, we're not talking about dynamic microphones. What we're talking about is dealing with the sound, the dynamics of the actual waveform, the signal, once it's in the computer or once it's as an analog signal as well. You can use dynamics processing. So what a noise gate does, this is a very cool tool that's used a lot in audio. Some of you may be using noise gates now, in your broadcast. So it has a bunch of switches and dials here, and I know it looks a little intense, but I'll kind of explain what this does. So if you can imagine a sound coming in, okay, this blue line, what ends up happening is once the sound reaches a certain threshold, so you can actually, where's the threshold on here? Right there. You can set the threshold to a certain level, okay? And what that does is, hey, when the signal reaches that threshold, it does something, okay? And what it's gonna do is this. So the threshold, in this case, the sound coming in doesn't meet the threshold, right? It's below the threshold line. But once the sound goes above the threshold, something happens. Once it goes above, the output, so in this case, this is what the sound is coming in, and this is what I'm hearing, the red dotted line, okay? So the sound coming in, it's below the threshold, what happens? I don't hear anything. It's gated. It's literally, that's why they call it a noise gate. It's like, you cannot come in, you're beyond the threshold. You're below the threshold. But what happens after it comes in, or after it meets the threshold? All of a sudden, the gate now starts to open. And this attack parameter controls how fast it opens. Okay? Very cool. So now it's open, and the sound is coming in, right? And now the sound goes below the threshold. But notice, it doesn't completely stop the sound. The sound is still being heard, albeit at a lower level, via this hold parameter, okay? And once the hold parameter is, so I could set the hold parameter to a certain, half a second or milliseconds, and all the way up to 1 or 2 seconds. Once, whatever it's set to here, let's say 50 milliseconds, then it still yet doesn't shut off completely. It goes into release mode, and then you can control how fast it releases. So you're essentially shaping the wave by using a gate. And there are, one example is the drummer Phil Collins from the band. He was the second guy in Genesis, but anyway, that's a long story. But he was kind of known for a gated drum sound, and he would use gates, noise gates, and reverb to create a really kind of cool sound that had this like, kind of sound to it. Anyway, he was kind of known for using a gated drum, and there's all kinds of fun stuff you can do with gates. But from the standpoint of speech and in a broadcast, this is a very handy tool. And it is available. You don't necessarily have to buy an external piece of hardware like this in the analog domain. These are now sort of replicated digitally in the form of some software that you can do. And I'm going to demonstrate this a little bit later in software. Yeah, did you have a question?
I just wanted to set
the microphone, sorry.
Yeah. I'm pretty sure there's a noise gate built into OBS.
Correct, yes. I'm actually going to demonstrate that.
I'm sorry, I absolutely have to ask this question.
Sure.
What is the duck button?
Duck?
The duck button.
Yeah.
I really wanted to either quack at me or to spawn.
No. It allows you to do. What is ducking actually? I can't remember.
I just Googled it.
Yeah. Go ahead. You want to explain?
Basically.
It's been a while since I've used this particular noise gate with the duck. Yeah.
I saw a duck in the compressor feature, and what ducking does is it lets you quiet down your primary signal when you have a secondary. So if you're playing music and a game and you want that to be loud until you speak, you'd put ducking in your compressor on your gain.
Oh, right. Yeah. Is that a side chain?
Side chain.
Yeah, so it's a side chain.
Concept of side chain. So side chaining is you have to feed in like your mic and your like game or music background audio.
How many of you are using side chaining in your solution? Oh, you are? Okay, great. That's good to see. Yeah, so side chaining, and I apologize, I'm not going to cover it in this particular, but it's a more advanced implementation where you can use noise gates and compressors together to where they can actually, once a threshold is reached, it actually can do something and then it comes back. And as someone mentioned, sometimes I want, when I'm speaking, other sounds to come down, and then when I stop speaking, the sound to come back. And that's what the side chaining allows you to do. Yes, back there.
This is a little tip or problem I had. Windows has that built in with the communication functions and stuff.
With the noise gate?
The ducking.
Oh, the ducking. Okay.
So it will mute or lower other volumes. It can when it's detecting something on a communication channel. And
Okay.
when I was setting up my stuff, it was the hardest time because it would sound right, and then we'd start doing something, and then the sound would go away, and it took me forever to figure out what was going on.
Oh, and then Windows was doing that? Oh,
Windows.
Oh my gosh, that drives me crazy. Yeah, that's, gotta watch for that sometimes. Yeah, thanks for the tidbit on that. So that's a good thing to know in case you get that. It's like, what's going on? Okay, cool. Everyone clear on how, on a basic level, how a noise gate works? This could be your best friend. Yeah. Yes? Doing great, Ty. Getting exercises.
So would something like this be useful? Let's say you have your own streaming room, you're streaming and you have essentially lower sounds coming, let's say someone in another apartment that you can't hear very well, but like in person you could hear, on audio you could faintly hear. So that would be a good tool?
Perfect for that.
Okay, cool.
Yeah, sorry, I was gonna say that, you know, I have a problem in my place with the refrigerator or the air conditioning. Sometimes in the summer, and it's really hot, and you're like, oh man, I gotta have the AC on. But that hum is like, you know, kind of noticeable, right? And you can hear it, and you know, especially if your computer or your mic is nearby, it picks up that, and that's exactly what the noise gate can do. Yeah, absolutely. Yeah.
I've gotten this question before from people, so it's worth pointing out. The noise gate doesn't make the noise go away when it's open. So as soon as you start talking, you can hear the AC.
Absolutely, that is correct. Yeah.
And people have asked, like, I've got the gate on, it's working great, except I hear the fridge every time I talk, and I'm like, yep. Yes, you do.
Absolutely. So that's a good question. So what I would do in that instance, and I'm actually very glad you brought that up, because that's now getting into why you would choose the right microphone. Okay? Because if you have an omnidirectional microphone, it doesn't matter if you have a noise gate on, right? Because as you said, when the gate is off, right, when you're speaking, all that sound is being picked up. And then when you stop speaking, it goes quiet. But what you want to do is eliminate all that noise completely, or as much as you can, reject as much of that noise as possible. So that's why getting into, you know, if your microphone is meant to just record you, you want it as close to your mouth as possible. Now, obviously, that could, you know, that's a problem if you got, if you're streaming, right? Because you don't want to block your face. That's why on some of those other podcast photos I was showing you, they position the mic that way because they're trying to make sure it's aimed at the mouth and it's close enough, but not like, you know, an eyesore for the camera. What's that?
They want to make sure it's out
of the camera view, exactly. So it's not blocking your face. So that's where, you know, you're going to have to use mic placement. You're going to have to use all these tools together to kind of get that sound. But you're right. A lot of people, and I've noticed that, they'll have, you know, really, unfortunately, the wrong mic, despite using a noise gate, and then they complain about having that noise in the background. Everyone know what that sounds like? I'm sure we all, yeah. So, okay, cool. I hope this helps. Cool. So this is another cool tool called an expander, and it's I think it's a secret weapon that not a lot of people are aware of. So an expander kind of does the same thing where you have a threshold, and once that threshold is met, instead of blocking the sound completely, what it's doing is actually pushing the sound down in volume, as opposed to not. So in other words, a gate literally just stops the sound completely, whereas an expander keeps the sound, it just pushes it lower. So in this case, so here's the input, okay? So we have a sound coming in, it's not too high, then it gets louder, and then a little bit lower. So once with the settings set up here, here's the output. So what was this level is now this level, right? And this level stays the same. You notice here it's a little bit louder, here it's less. So while a noise gate can be useful, this is also another tool that a lot of people use, yeah.
Is this also called a compressor, or is that slightly different?
So in this case, this is actually, this particular box is a compressor and can switch to an expander, right? So in this case, this SSL module allows you to actually switch to both. If you see here, you can just go into expander mode. Yeah. So what a compressor does is basically the opposite of this, right? So what a compressor does is when the sound input comes in, it's actually going to make it louder, even louder than the input, right? And that's a great way of sort of bringing a little bit more level to your sound, right? It actually helps boost a little bit more. And there are certain types of compressors that are called compressor limiters. And you can set it in such a way where it'll boost pretty high, but once it reaches the limit, it won't actually go above beyond that. And that actually, what that does is it causes the sound to actually be pretty dynamic. So you can scream and shout and whisper, and it's the same level, right? That's kind of an extreme compressor limiter setting. So it's very, very handy. But it can also be dangerous if you don't know what you're doing. So yeah, so just be wary of using a compressor, because if you've got a noise issue, if you have background noise, ambient noise, heavy compression is going to bring all that up, all of it. So be very careful how you use a compressor. All right. So as far as tools, I want to kind of dive into a couple of things. So, but before I go into there, I think I want to show you guys a demonstration of the noise gate in OBS. So who here has OBS? Oh man, just about everybody. Okay, cool. Is everyone using the noise gate in OBS? Okay, so well, I noticed a few hands are up. So you guys want to see how noise gate is operational in OBS? Cool, yeah. Awesome. I'll go ahead and show you. So let me go ahead and mirror my screen. Okay.
Now I can see behind the scenes.
Yeah, behind the scenes. So I have here, where's OBS? Okay. So, oh cool, I have some microphone coming in. So I'm using the microphone off of my laptop, and you're not necessarily going to hear the audio because it would cause like a delay and stuff. So, but what I want you to do is notice here on this level here. So I have a noise gate on here. I'm going to show you how I did it, but I want you to just kind of notice something. You notice what the input is here on the audio input capture. So I have two things going on here. I have the audio input capture and mic, right? So it's the same thing in this case. They're both the same sources. So watch what happens when I stop speaking. See that? That's the ambient noise. But the mic, because it has a noise gate on it, no noise. So let's go ahead and see how that works. So I have here, if I go to filters, I can actually, you can kind of see here what's going on as well. I'm going to actually bypass the noise gate. And you'll see that as soon as I did that, look at the background noise. Right, turn it back on. Background noise goes away. So you can imagine what that would sound like. The hum of the computer and all this other stuff in the room would be heard if I had it bypassed. But you know, if with it on, that goes away. But as soon as I speak, right, and I've met that threshold, it turns on. So here are the settings for that, and you can actually go in, and you remember that diagram of the threshold and the attack and hold and release? That's all there, yeah. Oh, I'm sorry, yeah, waiting for the mic.
So what would you recommend for the close and open? You might be getting to this shortly, but to keep it in between, because you don't want to have it like -38 and -26, right? You want to have it like within what, 6 to 8 of each
That
other?
really depends, because this is the default, and some of the, you know, the default does a pretty good job on its own, but it may not work for everybody. So I would recommend actually, like, what you want to do is just make sure that the close is lower than the open. That's for sure, right? But you may want to tweak it. Yeah. Does that make sense, Hexor? Yeah. I wish I could give you like, oh, use this and this, because it might change for your environment.
Your mileage may vary, so
Yeah.
every room, every setup
Right.
is different. So
Yeah.
play around and experiment using what was covered here as a starting point.
Absolutely. Now, I want to show one other filter. So if I remove this, and I remove that completely, there is another, the noise suppression. And the noise suppression is basically a lot simpler. I mean, it's just one parameter, if you will. And you notice, just the default, I didn't change it. I mean, I think it's set to that. Let's play around with that a little bit. If I bring it lower, oh wow. There we go. See how it's basically virtually like it's not doing anything. It's just, the really high value basically means it's always on. Or it's always, the gate is open, if you will.
Does the opposite suppress your own voice?
What's that?
Oh, huh, okay.
Yeah, yeah, when I went the other way, it totally,
Yeah, I was just wondering if you had it on the other way, if it suppressed your own voice if you talked. That when you had the suppression all the way down, or the opposite way. Yeah, really high, I guess.
yeah, I don't think it's doing what, yeah, it's just basically a real easy noise gate.
Yeah.
Yeah.
Awesome.
Yeah, because I'm looking at it here, and it seems to be identical, right?
Yeah.
Yeah.
Nice.
You know what it is? It almost like they have like a default hold, release, all that kind of built in,
Yeah.
right? So, because I noticed you can see as it's trailing off, it's kind of has a time to it, right? So yeah, it's kind of got a default. Anyway, I just thought I'd point that out in case anyone wanted to use that. So, yeah, does someone have a question? Yes?
You said, maybe you answered already, but you said the defaults, like, can you open the?
Yeah, the other one?
Yeah.
Sure. So noise gate.
So I've tried with all these, but I was doing, so it didn't seem like it was doing anything. But what's the difference between the hold time and the release time?
Okay, yeah, that's a good question. So if I go back to, I think it'll be helpful if I go back to the presentation for that one. So I'm going to close out of this real quick. What happened to my presentation? Oh, there we go. If we go back to this slide, can you guys see that? I'm going to hit that here. So the hold and release means that once the sound goes below the threshold, it's not going to just immediately stop. The gate is going to allow the sound to kind of hold, so that it's going to stay open but at a lower volume, right? And then eventually the release kicks in, and the release also has a time. So it's kind of, once the threshold is met, something happens. Once the threshold goes up, or you pass the threshold, on the way up, it does the attack. On the way down, if you pass the threshold, hold and release engage. So it still holds it, and then the release. Yeah. And the reason why they do that is so you don't get an abrupt. I mean, you could set it that way where the hold and release are really, really short, and it'll be kind of an abrupt like transition. But this allows you to kind of make it a little bit softer transition if you so want it. Yeah. Does that help?
This could be questions for all you guys too, but can we see these slides later?
I'd be happy to provide them, absolutely.
Yeah,
Yeah, I was thinking about that
come back
earlier.
to this.
Yeah, I'd be happy
Thank
to.
you.
Yeah. Oh, my pleasure. Oh, yeah, sorry.
I've got a question when it comes to the open and close. I mean, it seems like it should be self-explanatory, but I've kind of fumbled with it because
No, that's
I'm
okay.
trying to understand it. So when the gate opens, obviously you're then receiving audio or relaying audio. Is the close, and why are there different levels? You know, I'm just trying to wrap my brain around.
It's just the way that you're talking about what's in OBS.
Yeah, like why would you set your open and close to be a certain? Why wouldn't they?
They're just adding more options.
Okay.
And you know, if you notice this one doesn't really have a hold and close. I'm sorry, an open and close. It basically has an open, and then they use the hold and release to get what you want. But the OBS one has this too, but they also on top of that have a close. So it's just another. I think it makes it more confusing.
Yes.
Yeah.
Because it's hard to understand. It's hard to understand.
I totally agree with you.
Why you would set your open and close at different spots.
Yeah. Well, I understand the confusion with that. Yeah. But just know that you have to basically work. I mean, unfortunately, that's the way they designed it, so you kind of have to use it. Yeah, yeah. No, I'm just saying, yeah.
But I'm just like still.
I agree with you.
I haven't 100% understood.
Right.
So there's a good reason that they have it, but it's also too confusing in advance, I think, as you guys have mentioned, really for most people to use, and that is when you consider how we speak, think about how you speak, think about how I'm speaking right now if I'm talking, and then I have a pause, and then if you have that gate threshold lower at the tail, that means if I trail off here, but then I get back into it, the gate's not going to shut simply because I can't hold the threshold because I'm talking.
So it's like two thresholds.
Exactly.
Yeah.
And so if you have the gate constantly opening and shutting, you hear that.
Yeah.
It can be a little jarring if it's constant because that's your pace of speech. But
that's what the hold is for.
That's what the hold's supposed to be for, yes.
Yeah.
But
See,
if
that's
you're,
my thing. Yeah.
Like Obama, and you'd speak like this, you're going to hit the gate constantly.
Right.
It'll sound weird. So that's why they have it, but it's really.
But it's redundant, wouldn't you say?
Yes.
Because of the hold, and that's what makes it confusing.
Yeah.
Yeah, I agree with you. Yeah, it confused me when I tried to figure out what's going on here. Yeah.
I think the hold's there to help engage with people. Because, I mean, if you just drop off audio, like he's saying, you lose that engagement.
Absolutely.
Like, if you trail off and it ends, you lose that engagement. So
But they're talking about not the hold here. They're talking about an OBS.
right,
Here, I'll
it
show
just,
you.
like, ends. It
No,
doesn't-
in OBS, there is. Here, I'll pull it back up here. Just in case anybody missed it. If we go to the noise gate, there are two thresholds. That's what they're talking about. So this open and close in addition to the attack, hold, and release, right? So this secondary close threshold, we know what the open threshold does based on that other diagram, right? As soon as I go up and past the threshold, the gate is open, right? So the closed threshold is what makes it confusing because it's, as I didn't get your name, but as he was saying, those pauses in the voice, you know, you don't want the gate to immediately just like shut off because then it would sound unnatural, which is why we have the hold and release. But that's what this attempts to do as well. The closed threshold is you know, it attempts to basically give a range. So a secondary threshold, so if there's like a mid, you know, it's a transition, if you will. But it's basically redundant. But this is the way I understand it. I think this entire room kind of agrees. So, yeah. So, How are we doing on time, folks? I apologize if we're reaching 9 o'clock. So if you don't mind, I want to show another tool. Anyone familiar with Voicemeeter? Cool, awesome. I'm going to show you guys Voicemeeter, and then I'm going to show you guys another quick tool here. So what I'm going to do is switch out of here into PC. Because Voicemeeter doesn't run on Mac. I use Mac a lot for work, and then of course the PC for this stuff.
Unbanned.
So I have
perfect for streaming.
What's that?
Unbanned.
Yeah.
Perfect for streaming.
Yeah. But let's see. I have. Oh, sorry guys. Quit out of this. So Voicemeeter. I have it set up already here, but I kind of want to explain. Is it who here has used Voicemeeter or is familiar with it? Okay. And
I've also spent hours getting frustrated.
Frustrated with it? Yeah. It's a I'm gonna try to explain some of it here, and hopefully it helps. But I find it as a great, like, just if OBS on its own, I think it's a great tool. But how many of you are dealing with multiple audio sources? Okay, I would imagine. So just for example, I mean, music, let's say you got Spotify or you got some kind of, what's Pretzel, right? If you got some kind of Pretzel, we've talked about this before in our meetups, is a kind of a sourced, where there's permission, where you can use music for stream. So that's a great website for that. Anyway, so if you're playing music, and let's say you have your game audio, you have your mic audio, and let's say you want Discord audio as well. How are you going to manage all that in a simple way? While you can do it in OBS, because OBS has a mixer, I find it not really intuitive and easy to access as a program like this. And then there's a third option, or I should say a third, but another option I'm going to explore that actually is a device that's a hardware device that some of our streamers actually here in this room are using that kind of does what this does, and I'll get to that in a second. So OBS gives you a nice intuitive interface that looks like what audio engineers would use, and that's a mixer, right? It's a very intuitive way to think about sound. So the way this is structured is you have a variety of inputs right here. So I have, in this case, Voicemeeter has different versions of the program. They have Voicemeeter, Voicemeeter Banana, it's kind of funny names, and Voicemeeter Potato. The only difference between those different versions are the number of inputs and outputs. That's it, for the most part. So I'm using Voicemeeter Banana. It's kind of the middle of the road one. It gives you 3 hardware inputs and 2 virtual inputs. There's another kind of layer to this that uses something called virtual cables. And what virtual cables are kind of like, they actually show up in your audio system options as like devices that you can use. And those are actually really handy, and I'll kind of show you an example here in a second. So the way I have this set up is I have, let's say, music, I have a different mic actually. In fact, I'll kind of also add it here, so I'll have 2 mics going on. Like 2 mics in the room. So, yeah, bad joke. You can see the level there. I have it unmuted, and what I'm going to do is actually bring this way down. I'm actually not even going to, I'm not actually going to engage it.
You're going to drag the window over a little bit. It's cut off.
Oh, I'm sorry. Yeah. Gotcha. Is that better? Okay. So the mic is muted, but you can see I'm getting level from the second mic that I have on. So, there's also, I have here a cable. Remember I was telling you about those virtual cables, and they're basically a virtual sound device? Let me kind of show you what that looks like in Windows. So when you go to System, in your settings, the app and volume settings. I don't know if you all know how to get here. I'm going to go back so you know what I'm talking about. So you know when you go to the sound settings and you go to the very bottom, this is actually a new edition of Windows. In the Windows Creator Edition, I don't know if you're aware, there's an update that came out last year called Creators Edition, or was it 2 years ago, I forget. So it's a version of Windows 10 that adds these cool new features for audio. When you go to other sound options, there's app volume and device parameters. You used to not be able to do this in Windows, but now you can. You can actually assign devices for different applications now, on an application by application basis. So if I, let's say, instantiate, if I have, where is my, hang on, I'm going to close my Chrome. Let me see if I can create a new window. Okay, go back here. Oh, that's weird. Because Chrome should show up. Maybe I have to go back to title. Let me try playing some music. Ah, there it is. Title Chrome. So now I can go in. I'm going to lower it down, sorry. What's this cool about using a mixer? I can just go in and just bring it down. Actually, at my setup, I actually have I have a very small touch screen. And I can now use this. I could use my fingers to actually mute and bring the levels and everything just with a touch screen. It's a small little monitor that's a touch screen as well. So if you notice here, I can actually go into the app volume and device preferences under sound settings and actually assign a cable that routes it to voicemeter. Again, you used to not be able to do this. How many of you probably complained where you have a bunch of different applications open and always come through one device? No more. You can actually separate that, yeah. Microphone.
There we go.
Yeah.
Does Voicemeter let me take my OBS sources and import them into here?
I haven't tried that, but you should be able to. What sources are you thinking about?
Well, so I got this crazy multi-camera mobile stream.
Oh, okay.
And I have basically.
You have audio with the camera.
Yeah, I have an EMG camera, so I've got left and right channels.
I haven't tried that. Does anyone know if that's possible? It's actually a really cool. Yeah. I don't know if you could do that in OBS. I'll have to take a look. Sorry. But yeah. So as far as Voicemeter is concerned, again, I just think it's a really cool app that allows you to manage the audio, and it can be a little confusing, but I'll kind of explain a little bit how it works. Yeah.
Another program that you can, I know you can do it built in Windows now, but there's one called Ear Trumpet. I don't know if you've heard of it.
Yeah, I remember you told me about that.
It's a fantastic tool that you can actually set. The same thing you can set here, but it's a little bit more intuitive.
Yeah.
So you can set like your Chrome is going to come through a specific setup. And for my setup, especially with the Go XLR, it makes life really easy.
Right. Have you tried, so I remember Ear Trumpet being around because of this, as a workaround for this situation with Windows.
Right.
Right? But now that the Creator Edition kind of addressed that, I wonder if Ear Trumpet is still...
I still like the interface of Ear Trumpet.
Oh, I see.
And it's a lot easier to get to. It pulls up another little Windows icon or a little sound icon on the bottom right of your Windows.
Yeah,
and you can actually just like click and drag. So instead of having like drop down boxes, you actually can like click like on Chrome and literally move it to which sound device you want to hear it from.
Cool.
And it's a lot. It's
yeah,
a lot
I
more
remember using it like a few years ago, but it sounds like they've updated it. It's got a better interface.
How are we doing on time?
Yeah. Let me see here.
8:55.
So we got, what, another half hour? Should be, unless, I could go fast. I just want to make sure we get through here. So I'll make it quick.
For that, so 9:30.
9:30? Okay. So we'll be.
How are you guys doing? 9:30 okay?
9:30 okay, or do you want to cut out of here like 9:15?
Hey, I'm not my fit in that. I'm still whatever.
You're okay? All right, well, I just want to make sure everything. Well, I'll try to make it 9:15, and then, we'll try to keep it short. So let me kind of explain a little bit of how Voicemeter works. So again, you got three hardware inputs, three virtual inputs, but also the same for the outputs. You have here, and again, in this version of Voicemeeter Banana, you have three hardware outputs here, A1 through 3, and then B1 and 2 are down here. Those are virtual outputs. And the way I set this up is I actually have my hardware output, A1, going to my headphones. And then B1 goes to OBS. So that's a virtual, that's a software happening on the software side. So because I'm using a hardware audio interface for me to connect my headphones, I'm using A1 because it's a hardware output. And then for the virtual output, I'm going to OBS. So let me show you here with OBS running. So let me get OBS. There we go. I usually have dual monitors, so this is like, or 2 or 3 monitors. So you can see here, I'm getting audio input from here. So I'll show you. I'm going to pull this off to the side. And if I bring this up, oh, sorry. Right? Now let's bring in another input. Let's bring in, let's say I'm going to run Overwatch. Well, we're going to hear music kind of combating, so hopefully that won't be too bad.
So much sound.
Yeah, exactly. Uh-oh. Didn't like that. So let me see if I can boost. There we go. So again, I got two combating things here. But basically I have the music from Tidal hasn't kicked in. Again, it's probably a bad example because I have two competing musical pieces, so sorry about that. But you guys get the point, that I can manage multiple sounds and it's very easy. Now imagine, again, using a touchscreen for this. So you can go in, and what's cool about it is you can go in and say solo, and just hear this, right? And if I wanted to, solo the game, I could do that. If I wanted to go in, because my mic's muted, and we know why, because there's dual mics competing, I could do that. So, again, using a touchscreen, this is the coolest thing, right? Because you could go in and just hit mute, hit solo, just whatever. So, yeah, go ahead, Ty.
No, I'm saying for the recording sake.
Oh, the recording sake, okay, yeah. So, so what's cool about this too, there's actually a noise gate. And let me see if I can, if I have the noise gate on now, notice how, let me speak really loudly in it, hang on, let me try this. Hello, hello. And the noise gate engages. Whereas if I turn it off, hello, hello. Oh, okay. So I guess the noise gate is a little. Oh, you know what? I don't have it on. I don't have the gain. There we go. So now the noise gate should be going here. So I probably have to. Yeah. Testing 1, 2. Testing. Yeah. So I got the noise gate going.
Does it work when it's muted?
Maybe it doesn't work while it's muted, yeah. I don't want to turn it on because I'll have two things going on. But yeah, that's probably why, because it's muted. Yeah, normally you wouldn't want to do this if it's muted, so that makes sense. Okay, so yeah, again, I'm sorry, this is kind of a quick, like, dirty sort of, overview of Voicemeeter, but it's a very handy program. It's very cheap. In fact, I don't know if it's still the case. It was free to download, but I think now the deal is you go to the website is called VB Audio, vb-audio.com, I believe. So if you go to VB Audio, you can go to their website. And I think the way it's set up now is they recommend $15, just like Donationware business model. So you can pay the 15, I'm sorry, not dollars, in euros, or you can pay €5, I think is the minimum, right? So it used to be where you could download it for free, and then if you wanted to, you can donate, but I think now they require at least a €5 donation. And the virtual cables, they sell them in pairs. So you can get virtual cable A and B, and they just released C and D. So you can get now 4 virtual cables, and those have a cost with them as well. I think those are a minimum of £5 each. But again, very useful. I just wanted to offer this as an option. As Hexor was saying, there are other solutions out there like Ear Trumpet, and there's a bunch of other stuff out there. But a lot of people are using voice meter. Now, I actually haven't used this advanced capability of it. You guys see here this V-band button here? So V-band is actually an audio network where you can actually transmit audio over Ethernet to other devices. So you can actually, and I haven't experimented, I will probably for a future update on this. I was thinking about doing a follow-up on this that's a bit more advanced, maybe as a panel with other speakers. But I was going to look into the capabilities of V-band because you can basically use that as a way to route audio from one computer. And if you have a secondary computer for streaming, for doing encoding, you can basically use V-band to send audio from one to another. So yeah, that's something that's kind of cool. Yeah. Yeah, so that's voice meter. And I think lastly, I just want to touch on one thing here, and that is someone mentioned earlier a tool that a lot of people are using, and that is a company called TC Helicon. Oops, sorry, can't type. TC Helicon. They have the Go XLR. Who here is familiar with the Go XLR? Yeah, a few people have it here. So it's a really cool device. So I want to touch on the pros and cons of that software I was just telling you about. Again, it's very low cost. It's very flexible. A little confusing, I agree. But once you get the hang of it, you know, there's a bit of a learning curve, but it's pretty useful. There's one particularly bad con, if you will, and that is processing power. If you're doing streaming, as far as encoding, so you're encoding video, and you're playing a game, and you're doing other things, and you're doing audio, that's where software, doing this stuff in software is kind of, a problem because of the processing power needed for audio. Once you start adding in noise gates and all this other stuff, it really boosts the processing power. So the Go XLR, what's nice about it is, first off, these faders are motorized, so it actually, you know, when you move them, it actually kind of can snap back to previous levels if you want. But there's also a whole bunch of other features. But one of the things I like about it is that it has noise gates, compressors, EQ, all that built in. And guess what? That's done offline. That's done off of the computer in this device. So you're now saving some of those precious computing resources, especially if you have a single computer setup. This is a very handy device. It's got a whole bunch of other features, like you can actually sample. I don't know if you guys know what sampling is, but let's say, I don't know, I say something silly or make a weird noise. I can actually record myself doing that and trigger it on the trigger pads, kind of like drum pads. So I go, hello, 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 hello. You know, I could do something stupid like that or whatever. So, and there's a bunch of effects, like you can do reverb. It may have a voice changer on it. Does anyone know if it has a voice changer? It probably does.
It does.
Yeah, I bet that's really fun. Yeah. Did you have a question?
One thing I do want to note about doing audio processing in software is that audio processing is by in nature of the nature of the work of audio processing. It's real time, and unless you schedule that real time, you're going to be. And if you're running encoding, if you're running gameplay at the same time, once you start having all of those tasks contending for CPU real time resources and scheduling, bad things are going to happen.
Absolutely, yeah.
Very bad.
And that's why this is a great option, and a lot of streamers are starting to go this route for dedicated hardware audio solutions, that mitigate that issue, that processing power. So, yeah, folks, I wanted to keep this short. I apologize for going over. This is basically the end of my presentation. I wanted to kind of open this up to questions and answers. I know we covered a lot of ground today. I appreciate your patience, and I wasn't able to do a deep dive into a lot of stuff, but yeah, I'll get the Hexor after. But yeah, go ahead. He's got the mic. Yeah.
Mike trumps all.
Yeah.
What I found the latest. Now I do actual music
performance and/or production on stream. So my requirements are a little tighter than most people. But
Yes.
how bad has the latency been for you with vMeter? Because for me, it was unacceptably bad.
Well, here's the thing. I have this Behringer device. I noticed it's not the highest end thing, Robin, but it has ASIO drivers. So one thing I noticed is, depending on the type of drivers you're using, if you're using WDM or you're using some of the other more, let's just say, less efficient drivers, MME, for example, really horrible latency. ASIO was a lot better, in my personal experience.
Right.
So what we're talking about here are types of audio drivers, and what you'll find is just a general thing. Musicians and audio engineers kind of know this. In the world of Windows, if you had to choose an audio driver, ASIO is far better than MME and WDM, which are two of the Windows like standard drivers.
Right.
Yeah.
And I found even with ASIO, the way voice meter is written, there's like, not that anybody else here.
It's not a perfect solution.
Yeah, it's like 7,000 sample
Yeah.
delay, like just built in. And I was like,
So what you could do is, what I've noticed is I can go in and change the buffer settings, right? So I can go and change, let's say if I want lower latency, now you bring up something here, and again, it's another topic, but what ends up happening is you can tweak, everyone knows about latency, obviously, and most gamers are aware of this, so I don't think it's like something completely new. But in the world of audio, it can be a bad thing where there's delays, right? Where you say something and then you hear it 10 seconds later, that's obviously very bad. That's an extreme latency. But even minute amounts of latency can be very distracting. So we obviously want to be able to lower the latency in such a way where it's not distracting for the audience or you. So what ends up happening is there are ways to tweak latency, and the better drivers and better software allow you to go in and change buffer settings for audio, okay? And you can actually modify the buffer settings so that you can, as you have larger buffers, it actually reduces latency, but what does that do? It increases processing power, right? So there's a trade-off, unfortunately. So you could go in and kind of tweak that in voice meter. It may not necessarily be the right fit for everybody, but at least you could go in there and dial it in, but there are trade-offs. Yeah.
Just want to say that with OBS Studio, there are ways of using it, there is an ASIO input plugin.
Okay.
But because of legal reasons about the software development kit of Steinberg, you're not.
Oh, because they're the developers of it, yeah.
You have to compile it yourself. And
right.
If you compile it, you're not allowed to share it with other people.
That's
it's pretty bad.
That's pretty bad.
You don't have to compile it.
Yeah.
There is so you don't actually technically have to do the compilation yourself. There is a binary you can grab. They just can't distribute it. I don't know how that works. Anyway.
No, thank you for bringing that up. Yeah, it's yeah.
So one of the things that was going back to the noise gate in OBS, the open and close threshold.
Mm-hmm.
The close threshold is actually similar to like a compressor. So basically, if you're like too loud, it's not going to open right away. So like if you somebody screams into your microphone, it's not going to pick it up right off the bat. Does that make sense?
Yeah, I can see that. Would the attack affect that though, as well?
Well, I'm not 100% sure of that, but like if you go back to the OBS and on that specifically, where it has the open and close, and you kind of saying it was redundant. It's not like the release, right?
Let me pull it up here.
So that's almost not a close threshold, but like a limit threshold.
Right. It's almost similar to the compressor aspect is what I was reading on it. So basically, where it has the open threshold is like the minimum you have to speak, or the minimum volume before it starts picking up the microphone.
Right.
And the closed threshold is if you're too loud, it helps preventing that peaking. Like if you have like a dog bark in the background, like when I had my dog's out there and I had that and she was barking really loud, it's going to.
So you're saying the closed threshold
right.
is if there's a sound that's too loud, right? Louder than your voice?
So what it says here is comparable to a compressor which attenuates signals above a threshold, such as loud attacks from the start of musical notes
noise gates attenuate signals that register below the threshold. The threshold is set above the level of the noise, and so when there is no main signal, the gate is closed. If that makes sense.
Okay, I wonder if is it attenuating though? Like what's it doing once the threshold is that's the part I'm confused about.
Right,
you see what I mean? Yeah, yeah.
Yeah, I think it cuts off. I think it doesn't like, if it starts too loud, I think it's just the same thing as that, the open thing. If you're too low, it doesn't pick up. If you're too loud at the very beginning, you're not gonna pick up.
Yeah, and then that's why we're saying it. Yeah, it's confusing. Yeah, I think, yeah, because the attack, that's what we were saying, what kind of affect that. But because what I noticed in the more like pro audio plugin, or not plugins, but the hardware, like the drummer noise gate, which is like a really great noise gate, that doesn't have that closed threshold. But I do want to understand, so maybe the lesson from this is that, you know, we can kind of research and see what that closed threshold is. Yeah.
If I may, I think that an open and closed threshold is very rare. We don't typically see that in noise gate settings, but I think that the closed threshold, in this case, it relates to the way, going back to what he said earlier about the way that people talk. When you begin speaking, you'll tend to enunciate and you kind of like, you start loud. It's very less common that we hear people talk in such a way where I'm going to start talking like this and then I'm going to get louder as I talk, right? That doesn't happen. Whereas when we talk, we usually start loud and then we might trail off and then we might start mumbling at that point. And that's the reason why they've added this closed threshold in there, is that they actually set the threshold of the closing of the gate at a lower level. And again, I've never seen that in any noise gate before, but that's what that is.
But then they're adding it in, yeah.
That's what that is.
Okay, so maybe, yeah, it's just another option, and maybe it's a little less, yeah, it's infrequent, but they offer it. Yeah. Cool.
Is there any other questions?
Any other questions, folks?
I covered a lot.
Yeah, we covered a lot of ground today. I really, really appreciate your
I want to do a
patience.
group photo before we all go.
Group photo? Okay, cool.
Yeah.
Thank you so much.
Oh, I hope it was helpful.
Just like everyone in the group, all come down here.
You want to change the lights in here?
Yeah.